Hey guys, hope everybody had a great weekend. I have so far. I'm filming this on Sunday night. It's been a good weekend. I've had time to kind of get some stuff done and just hang out with the family. So hopefully you guys have had a good time too. So today I'm going to try to keep this short and sweet. But today is going to be about two-step equations. Okay, and there is a reason I'm here with like a few of my besties. Because me and all of them are like this. Um, so I like to use a party analogy when I'm teaching two-step equations. And here's what I mean. So let's say you're having a party at your house. And let's say it's a small party. You've got your bestie there and you've got another acquaintance there with you, maybe multiple acquaintances. But when the party's wrapping up, when you're getting to the end of the party, who's going to leave first? Okay. Obviously, you're not going anywhere. You're staying there. It's at your house. So you're not leaving. But your acquaintances are probably going to be leaving first. And your bestie's probably going to stay there till the very end. Okay. So acquaintances will leave first. Then your bestie leaves. And then you're all alone. Okay. And here's how this relates to equation. So let's say this is the equation that we're trying to solve. Well, we know the goal of the equation is to solve for x. Okay, so we're trying to get x all by itself. And in the party analogy, x would be you because it's the party's at your house. You're going to be remaining and everything else is going to leave. So we want to get rid of the 3. We want to get rid of the 5 so we can find out what x is and then its value on the other side. So looking at this, the value that's going to leave first is the 5. Okay, one way you can kind of look at that is looking at the 3 and the 5. Look at which one is closer to the x, and the closer value is the 3. Okay, so that would represent your BFF, and 5 is your acquaintance. So again, whatever's farthest from the variable is what we're going to get rid of first. So go back to what we did with one-step equations. Remember, we applied the inverse operation on both sides. So since this is going to go first, the inverse of adding 5 would be to subtract 5. So my first step would be to subtract 5 from both sides of the equation. All right, then I'm left with, let's see, 3x equals, and on this side, 26 minus 5 is 21. All right, now I'm down to a one-step equation. So I know I need to get rid of the 3. So I'll divide both sides by 3. And that leaves me with x equals, and 21 divided by 3 is 7. Okay, now remember, just like we did with one-step equations, you want to always check your work by substituting your answer back in to the original equation. So the original equation, we had 3 times x, but we're saying that x equals 7. So 3 times 7 plus 5 equals 26. So again, all I did was I took the original equation and I've substituted my solution in place of x. Now work it out. So this is 21 plus 5 equals 26. So this side does equal 26. So I know that this solution was correct. All right, so let's look at this next equation here. So again, we know our goal in this equation is to solve for the value of x, okay? So that's you, because we want to leave you or your x all by itself or isolated. All right, the 15 right here is the acquaintance because it's farthest from the variable. And the 7 right here is the BFF, so it's going to leave last. All right, so we're going to get rid of this first. So the inverse of subtracting 15 would be to add 15. Make sure we do that on both sides of the equation. All right, that leaves me on the left side with x divided by 7 equals, and over here I've got negative 5 plus 15. So it's going to give me a positive 10. All right, now this is a one-step equation. So since I'm dividing by 7 here, my inverse would be to multiply by 7. So multiply both sides by 7, and that gives me x equals 70. All right, let's make sure we go back and check our answer. So instead of x in the original equation, I'm going to put my solution of 70. So 70 divided by 7 minus 15 equals negative 5. Sorry, I kind of ran out of space here. Let's see. So 70 divided by 7 I know is 10, minus 15 equals negative 5. Well, I know 10 minus 15 is the same as 10 plus negative 15, and that gives me negative 5. Okay, so I know that my solution here was correct. All right, let's look at one more example. Okay, so again, I need you to think about what step you would take first. In other words, like which value on this side would be like the BFF and which value would be the acquaintance. Okay, because remember the acquaintance is going to go first. Well, again, the acquaintance is going to be whatever's farthest from the variable. The BFF is going to be the one that's closest to the variable. Well, if I look at these two values right here, the 4 is closer to the variable. So that's like your BFF, and the 6 is like the acquaintance. So that means the 6 is going to go first. All right, so notice right here, this is x minus 4 divided by 6 equals 11. So I'm going to get rid of that 6 first. So the inverse of dividing by 6 would be to multiply both sides by 6. All right, that leaves me on the left side with x minus 4 equals, and this is 66. Now the BFF is leaving, so I'm going to add 4 on both sides, and I get x equals 70. All right, I'm going to check my answer by substituting it back in. So back in the original equation, instead of x, I'll put 70 minus 4 divided by 6 equals 11. All right, when I solve that, 70 minus 4 is 66. I'm going to write this over here. And 66 divided by 11 does equal 11. So I know that this is correct. Okay. So just a quick recap. All right, so just a quick recap on how to solve a two-step equation. So remember, first thing you want to do is determine the operation that is farthest from the variable, the acquaintance, and you're going to apply the inverse on both sides of the equation. Next, that leaves you with a one-step equation, and so using the operation that was closest to the variable, now you'll apply the inverse on both sides. And then lastly, once you've solved and you've gotten your answer, you'll substitute that answer into the original equation to check your work.